Section 2.6. Let's start. Basic functions. Basic functions. So these functions have please memorize it or know how to graph it. Which is how are you gonna graph any function? You're gonna pick for the x, find the y, and you're gonna graph it. But by just looking to the function, you have to know how it's look like. What's the first one? We already learn how to graph function by picking a point x, find the y, pick at least 3 points, you're gonna find the graph of the function. Now, this basic function, I'm telling you, have to stop there. So the basic function, let's check. The first function is what? X plus 3. What it says? Linear function. So the linear function, like here's an example. If you have like y equals 5x plus 6. So it's a linear function. That's the general form of the linear function. Always the intercept is going to be b. So this one is the value of b. It's intercept, the y-intercept form. And this one is going to be the slope. I'm going to go in details, but here's an example how it looks like. This is the intercept, the y-intercept, which is 0, 6. Okay? And this one is the slope. Linear function, that's how it looks like. Okay? Just a straight line. How are we going to graph it? There's two methods. You can use the intercepts, or you can pick points for the x, find the value of y, at least 2 points, you're going to get the same line. Okay? This is just an example in general. Okay? The second function is what? It's called constant function. F of x equal b. Let's write down an example about that. How it look like. Just pick any number, like f of x equals 6. F of x equals 6. What's that mean? What's the meaning of f of x?
Function of x is 6.
Yeah, which is mean the y. F of x is y. That means y equals 6. For any value of x, how much the y?
6.
6. So when you graph it, for x equals 10, how much the y? 1, 2, 3, 4, 5, 6. This is the point 6. So when x 10, how much the y? 6. When x is negative 1, how much the y? 6. When x is 0, how much the y? That's why it's a straight line. So, okay? For any x value here, the y equal 6. So, okay? Understand function. What about the next one? Identity function. Let's check how it looks like the identity function. F of x equal x. Now this same thing. That's how we learn to graph a function. Think any value of x. 2. How much the y? 2. Because when you put 2 here, the y is going to be the same thing here. X. Put 0. How much going to be? 0. Put 5. It be 5. Put negative 5. It's going to be what? 5. So when you graph these points, your function is going to be 100% like this. 100%. Okay? Like this function. Is that okay? It's called identity function. Next function was called absolute value function. Look like phi. How are we going to graph it? We already learned how to graph any function. So for the absolute value, if this is the function, I'm gonna create table with x, y, choose -3, 0, 3. Here's the 3 points. Now -3, plug in -3 here. What's the absolute value of -3?
Positive.
Positive 3. Put 0, 0. Put 3 here. Let's graph this point. Check here, the same graph. -3, 1, 2, 3 is going to be +3. That's the first point. With the 0 here, 3, 1, 2, 3, 1, 2, 3. The same graph. So any 3 points, you have to know how it look like the absolute value of x. V. Is that okay? Linear function, constant function, identity function, absolute value function, how it look like. Is that okay so far?
Yeah.
Next part, which is the quadratic function. Quadratic function. I have to. Alphabet x equal x squared. So this is called quadratic functions. Alphabet x equal x squared. How to graph it? The same thing. X, here is y. I need to pick at least 3 points from the domain. My domain for this function is negative infinity and positive infinity. So I'm going to pick one positive, 1, 0 with one negative point. Choose -2, 0, and 2. Plug in -2 here. 4. Because -2 squared is going to be 4. Plug in 0, 0. Plug in 2. Oh, so here is 3 points. Let's check. -2 here, and the y is going to be 1, 2, 3, 4. 0, 0. Here is 2, and the y is going to be 4. Okay. So this is the graph of. You can write down these points here, and every time you get the x squared function, how to graph it, you can use the same points here. You graph the x squared quadratic function. The same function, but check this side. This side is up here, and now with the new function goes down. It's the same function. See, it's exactly. But this side is going down. Why? This one is x cubed. Let's try to get a graph. Alpha of x equal x cubed. How to graph it? The same thing. xy. The domain from negative infinity to positive infinity. So I'm going to choose 3 points. -2, 0, and 2. Because the domain is negative or positive, so always I'm going to choose one negative, 0, and one positive. Is that okay? Let's check here. Plug in -2 here. -8. -2 times -2 times -2 is going to be 8. Plug in 0. Plug in 2. And -2 with -8. It is -2. 1, 2, 3, 4. Until 4 should be here. And 2, but let's keep going down. 0, 0, and 2, 8. 0, 0, and 2, 8 is 1, 2, 3, 4, 5, 6, 7, 8. It could be here. Gonna keep going out on this side. Still the same account. Okay. That's hard. But the main thing you have to memorize how it looks like the function and make everything easier. How to graph it? You can use the same point to graph it. Because the next step, we're going to do transformation on these graphs, okay? Next graph was called square root function. Who's going to tell me what's the domain for this function? 0 to infinity. You see, here's the graph. So the graph of square root, it's from 0 to infinity. That means I can't choose negative numbers. So when I graph it, I have to choose 0, 2, 4, and keep going. Okay? How to graph this function? X, Y. I'm not going to choose 2. I can choose 0. It's going to be 0, 1, 1. But if I choose 2, it's going to be square root of 2. It's hard to graph it. So I'm going to choose 4. What's the square root of 4? It's easier to graph this number. So 0, 0 is going to be here. 1, 1 here. With the 4, 1, 2, 3, 4. How is going to be? Exactly. So when they ask you to graph this function, you can choose these points. You can choose 9 and 3. Square root of 9 is going to be 3. It's going to be the same. It's just the graph is going to be more. Next function is cubic root function. The domain for this function is negative infinity and positive infinity. You can tell from the graph. From the graph, I can choose negative points and positive points. This one, check this side, kind of similar to this one, but we have the other side. That's why it's a cubic root of x. So, okay, how to graph it? The same thing, x, y. But now I can choose negative numbers. Let's choose negative 2, 0. It's going to be hard. Because I need to choose a number. 6 also going to be hard. Negative 8. I need to choose a number so I can have cubic root for this number so I can graph it. Which is if you choose 6, it's still right. If you choose 2, it's still right, but it's going to be decimal number. It's hard to graph it.
Like a 27 or something, right?
Yes. A number has a cubic root. So you can choose negative 8. What's the cubic root for negative 8? Negative 2. For the 0, 0, 4, 8 is going to be 2. Let's see. We can do that here because the graph until 4, but negative 8 with negative 2. So 1, 2, 3, 4, 5, 6, 7, that's going to be here. The graph is going to keep going down like this. And from this side, it's going to be here. The graph can keep going like this. Still like this. Okay, so to graph it, you can choose these numbers. Okay, so far? Last graph is what? Typical function, which is 1 over x. Check here, we're going to study that too. This function, because x equals 0 is going to be this line, it's called asymptote. We're going to study that later. The asymptote for this function. And this function always this side like this, and this side like this. Again, to graph it, choose any number except the 0. You can't choose the 0. You're going to tell me why. Why I can't choose the 0? Why the graph is not connected at this point when x equals 0?
The number divided by 0, 0?
No, you say it right. The number divided by 0 is undefined, not 0. That's why the function is undefined here. Okay? Because any number divided by 0 is undefined. So that's why the function is not connected here. 2 pieces. Choose 2 numbers here, plug it in the function, you can get this graph. Choose 2 numbers here, plug it in the function, you can get this graph. So, okay, we're gonna go more in details about this one. It's called asymptote. It's called vertical asymptote, not this section. Is that okay so far? The table here, the first transformation here. Remember that we have 9 basic functions. Now each function, we're gonna do transformation on, we're gonna get a new function. We're gonna shift it up, left, right, down, stretch the function, shrink it, okay? But how we gonna know that based on this? So this is like a rule. So check the first one. F of x here, it's mean one of these basic functions. So every time now here, when you see f of x over f to the x plus any number here, it's being one of these basic functions. Okay? So now let's check here on this one. We have transformation. We have vertical transformation. That means we're gonna move up or down. Okay? Based on what? If you see, this is the new function. If you see the basic function plus c, any number. C could be any number, 5, 6, 7 million. We're not gonna care about that. But that means the basic function is gonna be shifted up based on c unit. Okay? So if it's 5, it's gonna be shifted up 5 units. F of x is one of the basic functions we already studied. Plus a number, so it'll be shifted up 5 units. Let's check here. For example, if you have y equal, this is f of x. Let's choose one of these functions. If you have f of x, y equal f of x. Let's say y equal x squared plus 5. Check. This is the new function. It's basic function, right? X squared. We already know the graph of x squared. Shifted what? Shifted up 5 units. Okay? So when you go to graph this one, you're gonna graph the basic function, which is look like this, right? And then you're gonna say 1, 2, 3, 4, 5. You're gonna shift this graph 5 units up, so the new location is going to be here. Get the idea? That's what we're doing. Because this is basic function, shifted up how many units? 5 units up. Is that okay? What about if it's minus? Shift downward c units. Good, that's it. When you need to graph it, check what happened to the points. Each point on the original function, each point, you're gonna do this. X stays the same x. Y, you're gonna add c to the y. X, you're gonna minus c from y. So you're gonna get the new points, you're gonna graph it. If you know how to graph the basic function, you're just gonna shift it up. How many units? 5 units. It depends about the example. Is that okay? Because that's what they're gonna ask you. Shift up or down. Now, this is vertical. What about horizontal translation? That's different. Check where is the change? Inside the function. The change where? It'll be inside the function. Let's do the same example, the same basic function. I'm going to do change inside. At y equal x minus 5 squared. See the squared where? Squared is for the x. This is x squared. But check the number where? Inside with the function, inside the squared. So it's going to be which one? X minus, shift what? Be careful. When it's minus, shift to the right.
Yeah, it's opposite.
Yes. When it's a plus, it's going to be shift to the left. Is that okay? So be careful. So now this is shift left or right? The minus, so shift to the right. I know the basic function. But when I need to graph it, the basic function, I know it's look like this one. Now shift it to the right, so it's going to be 1, 2, 3, 4, 5. The new function is going to be here. I'm going to shift the whole graph to the. Is that okay? If it's a plus, it's going to be shift to the left. Is that okay? How to graph it? From the original graph, you can do these steps here to get the new point. Here is the old point. You're gonna add h to the y to the x, or you're gonna minus h from y to get the new point, so you can graph it. But the main thing, you have to know the basic function and what's that transition. If it's inside, I call it inside transition. It will be left or right. Outside transition, which is the number outside the function, is going to be up or down vertically. Okay? Is that fine so far? Back to the first example. Now let's do these steps here. And always you're going to go back to the same table. They ask you. Now we're going to try to graph both functions. First function we're going to graph is g of x equal square root of x plus 2. Now tell me, what's the basic function here? Square root of x plus 2. What's going to happen to the function? It's going to move up 2 units. Is that okay? Let's try to figure out how we're going to graph it. Now let's see. Check here the basic function. You choose the point 0, 1, 2, 3, 4. You go back to the square root of x. Which point we choose to graph it? We choose 0. And we choose what? Choose 4, right? So these 2 points to graph it. You give us the point. Let's graph the basic function. The graph's going to be here. Now go ahead. Plug in 0, and the point 0 is going to be what? This is the graph of the parent function. Here, these 2 columns will be the graph of the parent function. X0, the y is 0. X is 1, the y is 1. X is 2, go ahead and plug in the calculator. How much is going to be square root of 2? X3, how much is going to be? X4 is going to be 2. Tell me these 2 numbers, how much is going to be? You can get the value. So these points again, x, y, when I graph these points, is going to be the graph of the basic function, which is 0, 0, 0, 0. Okay. Next point is 1, 1. Here. The next point is going to be 1, 4, 1, 7, and 4, 2. 1, 2, 3, 4, 2. 1. The 2 going to be 1.4 kind of here. This one kind of here. Okay, so this is the graph of basic function. Now the new function is g of x. We have to shift the basic function how many units up? 2 units. Go back to the table, the chart, the big chart. Check on the side. You can add the value 2 to the x or the y. Let's plug in here. Here's the new function, right? When I plug in 0 here, it's going to be 0 plus 2. So the new point is going to be. You got it what I'm doing? I'm plugging 0 now here. Square root of 0 is going to be 0 plus 2 is going to be 2. Plug in 1 here. Square root of 1, 1 plus 2, 3. Plug in 2, square root of 2, which is 1.4 plus 2, 3.4. Plug in 1.7. 3, square root of 3 is 1.7 plus 2, 3.7. Plug in 4, square root of 4 is going to be 2 plus 2. Is that okay? Now let's graph these new points. 0x, y is 2. So maybe here. the new point. 1 is going to be with the 3. Here is 1, 1, 2, 3. Here. I'm going to jump to here. 2, 4. X is 4, 4. That's this one. 4. So 1, 2, 3, 4. And then other points, 3.4. 2 with the 3.4. Going to be the new graph. You get the idea what we're doing? The basic graph here, what happened to it? Shifted up how many units? 2 units. Each point shifted up 2 units. This is the new graph. This is the graph of square root of x. This is the graph of square root of x plus. Now, can you do the same thing with the graph of this is f of an x. So the whole thing here, what we did is the graph of g of an x. Now let's try to graph f of an x. Let's check f of an x. The transition where? In the x, inside. That means going to be left or right. When it's a plus, it's going to be shifted where? To the left. So here is the x. Now I need to find the y value. X is 0. What is 0 here? 0 plus 2. 2. Square root of 2. 1.4. You see the difference? Now, if I need to grab the new function, f of x, x is 0, y is 1.4. Now, plug in x is 1. It's going to be square root of 3, which is 1.7. Plug in 2, so it will be 2 plus 2, which is 4. Square root of 4 is 2. Plug in 3, going to be square root of 5. Plug in 4, square root of 6. So find square root of 5, square root of 6. Square root of 5 is going to be 2.3, I think.
2.23.
Yeah. So 2 point, let's choose 2.3. 2. Square root of 6. 2.4. 2.7. Okay. The same basic graph is going to be with this one. Here's the basic graph. This point. This point. The graph of the basic function. Let's grab the new one. 0 is going to be 1.4. 0 is going to be 4.
We're not gonna be plus or minus negative numbers, right? Just all positive numbers.
Oh, we forgot that. That's a good idea. But our domain here, square root of x plus 2. Remember, we check all the numbers inside greater than or equal 0. So x greater than or equal -2. So we can choose -2 and we can choose -1. It's going to be still right. Okay. But let's keep with these points because we choose here, they give us 0, 1, 2, 3, 4. So it's going to be the new graph 0 and 1.4. 0 and 1.4 is going to be next one. 1 and 1.7. 1, 1.7. 2 with 2. 2 is going to be with 2 here. So with 1.7, sorry, 3 with 2.2. 2, 2, 3, 2.2. Last one. Check what happened to the points. 4, 2.4. 1, 2, 3, 4, 2.4. Should be 0 with 1.4. It's not showing you how.
Put 0.4 instead of 1.4.
2, 0 with 1.4. The graph is right, but it's not gonna show how transition to the left.
It's because the graph you drew, you put the first point, you put 0.4 instead of 1.4.
1.4. Oh yeah, you're right.
We started at a different point instead.
Yeah. So it's 1.4 should be here. That means the graph is gonna go down here. Perfect. That's why you see it shifted a little bit, but we have to choose point from the left because our domain you can choose -1 and -2. Okay. That's if they ask you to graph it. But I always prefer to graph the basic function and shift each unit 2 units to the left. But with the basic function, we need to choose each point decimals. We're going to choose 0 and 4. 2 points going to be enough to graph it and shift it to the left. How many units? 2 units to the left. Okay, so far? So now, exactly the same thing. They give you the points. The first thing, what I'm going to graph, see, they're telling you here to graph what? Basic function. The numbers they choose 0, 1, 2, 3, 4. 0, 1, 2, 3, 4 is not going to help to graph the function because it's only what? It's only the positive side. And I know with x squared, I have 2 sides, the positive side and the negative side. So let's stick with 0 and 2, and we're going to add -2. Okay, small table here. Let's add -2 here. Okay. Why I'm choosing negative number? Why I'm choosing negative number? I'm not gonna graph this one. I'm not gonna graph this one. I'm not gonna graph this one. If you graph this, still right, but I need you to visualize. I'm choosing negative number because the domain for x squared is what? Negative infinity to infinity. So I can choose negative numbers and positive number. Now, if I graph only the positive side, I'm gonna get only this side. I'm not gonna get the negative side, but I need you to see the transition, how it looks like. So I'm gonna graph the negative and the positive side. So I'm gonna choose -2 here, and we have 0 and 2. Check the basic function, -2, plug in -2 here. It's going to be, sorry, plug in -2, it's going to be 4. I'm gonna write down the 4 here. Plug in 0, 0. Plug in 2, 4. Now, if we graph this point, we're gonna get the graph of the basic function. Let's check how it looks like. 0, 0, 2 and 4, 1, 2, 3, 4, and -2 and 4. So you see the graph of the basic function? That's why I choose negative number so I can graph the negative side. Okay? And we already know how it looks like the graph of the basic function on the first page, which is basic function or parent function. Now the new function h, what are we gonna do with the basic function? What are we gonna do?
Outside, so we're gonna move to the
Down
Down, how many units?
twice.
2 units. So you have, check. Before I'm going to put the numbers here, I already know, I need to shift my basic function. This is the graph of the basic function. Shift it down, how many units? 2 units. I'm not gonna do that, I'm not gonna look to the table. I'm gonna go to the graph. Shift each unit, each point here, how many units down? So 100%, this point is going to be here, right? This one, 1, 2. This one, 1, 2. So the new graph, shifted down, how many units? Shifted 2 units down. This point shifted down, this point shifted down 2 units. Get the idea? So let's go back and get the points. 0, if you plug in 0 here, -2 is going to be -2. 0, -2, is that the same point here? 4, -2, plug in here. -4, -2 squared, 4, -2, -2 and 2. What is this point? -2 and, so this point shifted this location. 4, 2, plug in the 2 here, so it's going to be 4 -2 is going to be, which is this point is shifted where? Here's the new graph. You got it? So it's up to you. That's why I never use this table. I always graph the basic function and do the transition on it. Shift it down, shift it up, left, right, okay? Now with the new graph, graph, I'm gonna graph the basic function, which is -2 and 4. So the basic function is the graph of x squared. The blue one is x squared, and this is the graph of h. This is h. And now this is x squared, and we're gonna graph the new function, which is check the transition where inside minus, that's mean left or right? Right. So this graph is then shifted to the right. How many units? 2. That's mean I need to shift this point 1, 2. Shift this point 1, 2. Shift this point 1, 2. So the new graph is going to be what? Okay. Let's plug in with the numbers here. -2. Plug in -2 here. -2 -2. -4 squared. This really way off from this. Plug in -2. Plug in the 0. -2 squared is going to be 4. Right? Numbers they plug in. Be way off from the graph. We can't graph it. -2 is going to be -4 squared. So it's going to be 16, which is really way off from the graph. Maybe -2 and 16. Plug in the 0. Maybe 4. Which is 0 and what is 0 and 4? 0 and 4, which is this point. You see? 0 and 4. That should be this one. Because we shifted So that this point, the new point here, is going to be really off of the graph. And then the other point is going to be 0, 4, which is that's what we got here, 0, 4. And the other point, plug in 2, 16, this is 4, plug in 2, 2 minus 2, 0. 0 squared is going to be 0, which is the 2 is going to be 0. 0, 2. See, that's why we get only these 2 points. And the third one is going to be really off of the graph here.
You do 4, right? So
You can do 4, yes.
it'll give you that last point.
You can get, you're talking about this point?
Yeah.
If you plug in 4, plug in 4 here, 4 minus 2 is going to be 2 squared. 2 squared is 4, which is 1, 2, 1, 2, 3, 4, 4, which is this point. Got it? That's why I prefer you graph the basic function and do the transition on it. Figure out how it's looking like. Because the first point here, 16, is going to be really way off of the graph here. And -2 and 16.
Yeah.
And probably here. So okay. C of x equal x plus 1 squared minus 1. How many transition we have? We have 2. Horizontal shift where? Horizontal shift, left or right? Left. So left, how many units? 1 unit. Units. Okay. What else? We have vertical shift. Where? Down. How many units? 4 units. Okay. That's most of the time they ask me. They need to, and the basic function is what? F of x equal x squared. So here is the basic function. We're gonna shift it to the left 1 unit, and then we're gonna shift it down how many units? 4 units. Now, go back to the basic function. How are we gonna graph the basic function here? X, Y. Remember the points I give it to you? Did I give you these points? These points to graph the basic function. -2 plug in here is going to be 4, 0, 4. So if I graph this point, it's going to be the graph of the basic function. -2 and 4, 1, 2, 3, 4, 0, and it's going to be 2 and 4. So I know this is the graph of the basic function. Okay. Now I'm just going to look at the basic function. I'm going to shift it horizontally left 1 unit, right? So each point here, I'm going to shift it 1 unit to the left. 1 unit to the left. So where is the new graph? Okay. Each point shifted to the left 1 unit. Then each point we're gonna shift it down how many? 4 units. Here is the new 1, 2, 3, 4. So the new location is going to be here. This point here, 1, 2, 3, 4. This point is going to be here. So the new graph is going to be get the idea? kind of. So I grab the basic function and do the transition on it. Left, up, down, which is gonna add more transition when it stretch and shrink. Is that okay so far? If you check here, I don't know how they give it the graph like this, the scale. That's why it should be in the middle. When you graph alpha of x equal the absolute value of x. Remember the point 0, sorry, x, y. You can choose, we already chose -3, 0, and 3, right? This is the point, right? Write down these points. You can choose any number, it doesn't matter. But the main thing, all the y value is what? It's positive. But I know the domain for the absolute value is negative and positive. That's why I have to include negative number. How many transition? Horizontal shift where? So right. How many units? 2. And vertical shift, up or down? 3 units. Okay. Now I'm gonna grab the basic function and do this transition on it. Basic function -3, 3, -3, -3 here, and the 3. This is 0, 0, 3, and 3. Basic function. Now let's do the transition on it. Doesn't matter which one I'm gonna do first. The result is going to be the same. To the right, how many units? 2 units. So I'm gonna shift 2 units to the right. This point is going to be here. New point here. This one is going to be here. So the new graph. There's the transition. It's going to be like this. Okay. Now we're gonna shift up how many units? 3. So 1, 2, 3. This point 1, 2, 3. This point 1, 2, 3. This is the new graph. It says vertical stretch or shrink. Now, vertical stretch, you're gonna hold the function like this and stretch it. Okay, so it's not gonna shift it. No, stretch the function. Or shrink, you're gonna press on the function to shrink it. Is that okay? So for example, just like simple example, if you have this function, you stretch the function, you're gonna hold it from here and stretch it up. So it's gonna be skinnier. Looks like you stretch a rubber. Is that okay? If you shrink it, you're gonna press on the function, so it's going to be what? Wider. You get the idea? But how are we gonna do that? How are you gonna just look to the function, you're gonna know it's a vertical stretch or shrink? Check this number here. If there is a number outside the function, I'll give you a simple example here so you can know. Like for example, if the function is y equal a alpha of x, y equal 3x squared. See, there is a number outside the function with multiplication. You get the idea? So this one is going to be vertical stretch or shrink. Okay? Let's do 2 examples here. If you have y equal 3x squared, there is a number outside the function, so I know it's a vertical stretch or shrink. But vertical stretch, if the number is greater than 1, it's 2, 3, 4, 5, 6, it's greater than 1. If the number is greater than 1, so it's going to be what? Vertical stretch. If the number is between 0 and 1, what does that mean? Fraction. 1/2, 1/5, 1/6, 1/10. The number should be between, but it's fraction. So, okay, so here's another example. Y equal 1/2 x squared. So when I see the number here, between 0 and 1, it's a vertical what? Shrink. If I see the number here greater than 1, it's a vertical stretch. The important thing, how are we going to do that on the graph? How are we going to do that on the graph? Remember, the first thing, we're going to graph the basic function. So I'm going to graph the basic function based on the points we have, okay? Then what I'm going to do, keep the x, replace what?
Y by
By ay. So the y point here, I'm going to multiply it by a. That's the idea? So first of all, you're going to grab the basic function, and then you have at least 3 points, right? You picked 3 points. The points you picked to grab the basic function, I'm going to take the y and multiply it by the a. I'm going to get a new y for each point. Then when I'm going to graph it, I'm going to get the graph, the vertical stretch or vertical shrink. Is that okay? I'm going to do an example. But I need to jump to the next one. Check here. This is an important note. The graph is stretched, shrinked vertically by a factor of a. They're going to ask you these questions when you're doing the examples. Factor of a, which is the number here. The factor of a here is a 3. What's the factor of a here? 2. Be careful here. Is that okay?
So 2's a factor, is not like
Half. It should be half, but a little confusing here. It should be the factor half on this one, because between 0 and 1. So what is this example? Now this is what? It's a vertical stretch or shrink. The same thing, but check the number where? Number inside the function.
stretch.
So it's going to be what? To a number inside. For example, y equals 2x. See? The basic function is square root of x, but there is a number where inside. Or y equals square root of 1/3x. Is that okay? Now let's check here. Horizontal shrink. How does it look like horizontal shrink? Horizontal shrink. You're gonna press on the function from both sides. Horizontal stretch, you're gonna stretch it for both sides. Is that okay? But how does it look like? If a is greater than 1, what are you gonna do? Horizontal shrink. If a between 0 and 1 is going to be horizontal stretch. Is that okay? How are you gonna do that? Check. This is for the basic function, the points. After you grab the basic function, what are you gonna do? Place x, you're gonna divide it by. You get the idea? So each point here, I'm gonna take it and divide it by a to get the horizontal shrink or horizontal stretch, and keep the y value by itself. Don't do anything, okay? This is how we're gonna do the horizontal shrink, the vertical, the horizontal if it's shrink or stretch. Okay, we're gonna go back and do the examples. Let's graph Oh, they give us tables for each one. For the x squared, if I need to grab the basic function, plug in -4 here is going to be 16. Plug in -2 is going to be 4. Plug in 0, 0. Plug in 2. Plug in 4. 16, we can't graph 16, so I'm going to stick with these 3 points. -2 with 4, 2 with 4, okay? But you can try it. Let's graph the basic function for the first one. We have until 8. So -2 with 4, -2, 1, 2, 3, 4, to be here. 0 here. So this is the basic function. Okay. Now, with the first function, 1/4 outside the function, what's going to happen?
Shrink.
It's going to be shrink the graph. How are we going to get the new y? We have to multiply a by y. How much the value of a? -4 is the x. Multiply
16.
16 by, look to the table, go back to the table you have.
1/4.
1/4. It says multiply by a. So 1/4 by is going to be, first of all, it's going to be horizontal, vertical, stretch or shrink. First of all, when there is 1/4, don't 1/4 outside is going to be vertical stretch or shrink.
Maybe shrink.
It's going to be shrink. That's mean this graph, what is happening? I'm gonna hold it from here. I'm gonna press. So the y value here should be here, right? This y value should be where it's gonna be shrinking. So you're gonna multiply y value on the basic function by a. How much the value of a? 1/4. So 16 times 1/4, 4. -2 times 1/4, -2 times 1/4, -2 times 1/4, simplified, going to be negative 1 over
You gotta do the 4 times the 1/4.
4 times, because you can multiply with as a decimal, right?
You can multiply this one here.
So 4 times 0.25 is 1.
They're doing the y times the.
Oh, the y. You're right. I multiply the x.
Yes.
I did mistakes. Thank you. So 4 times 1/4 is going to be 1. Perfect. 0, still 0. 4 times 1/4, 16 times 1/4. So now, this is the x value, this is the new value, y value. So it's going to be -4 with 4. Where is -4 here? It's out of the graph. Let's start -2 and 1. So -2, the new point is going to be with 1. It's too much shrinking. Another point, 0, 0, still the same. Another point is 4 and 1.
I have a question.
No, 2 and 1.
The -2, we multiply it by 0.25 or we multiply by 1/4 and it'll give you the 1 or?
No. Go back to the table. It says to do the vertical shrink, you're gonna multiply y value on the basic by a.
Okay.
The y value.
Oh, okay.
So 16 by 1/4 is 4. 4 times 1/4 is 1.
Okay.
0, 4 times 1/4, 1. You get the idea?
Yes.
But I can't graph these points because the graph, in fact, we can graph this one. -4 and 4, which is 1, 2, 3, 4. 1, 2, 3, 4. Here. Here. which is the point -4 and 16. -4, 1, 2, 3, 4. Let's say here. What happened? Let's grab the whole. This one like this. Look what happened to the graph. The first point is what? -4 and 16, which is this one, okay? Shrink to which one? Shrink to this new point. So the new graph is so -16.4 shrink to this point. This point -2 and 4 shrinked. Which one? -2 and 4 shrink to -2 and 1. 0, 0. This point is -2 and 4 shrinked to 2 and 1. And this one is what? The last one is 16, 4 and 16 shrank to 4 and 4. See what happened to the whole graph? The blue one is shrinked to the black graph. Pressing on the graph from the top to shrink, to push all the points. And the graph is still fixed here. Get the idea? That so far. Now, if you flip the page, next example. Reflection, we have two types of reflections. We have if there is negative sign outside, what you reflect over x-axis. That's mean reflect like this. So for example, for the square root of x. We already know we have f of x equals square root of x. The graph is going to be like this, right? Yes or no? So if I want to do reflect over x-axis, that means the function, let's say if we have f of x equal square root outside negative square root of x. So what's going to happen to the graph? Reflect over x-axis. That means the new graph is going to be where? Okay? Is that okay? Like, how are you going to do that? xy replaced with what? X negative y. Is that okay? We're going to do an example. If it's reflect over y-axis, what are you going to do? xy is going to change to what? Negative xy. Is that okay? Let's do an example. Reflection example. Let's do an example here to do the reflection. Have of x equal let's do root of x. We're gonna do x squared. negative x squared. And we already know the graph of the basic function. What? Choose x, y, choose -2, 0, and 2, right? I'm graphing the basic function. I plug in -2 here, 4, 0, and 4. So this is the graph of basic function, this one. It's mean 1, 2, 3, 4, 1, 2, 3, 4. This one is going to be the graph of the basic function. Okay. Now let's do the reflection. Negative sign outside the basic function. So the new point change what? Change the x or the y? The x. The x is what? Negative. I have to change it to what? This one should be goes down. So go back to the table. Which one is going to change? Negative sign. Which one we have to change? The y, not the x. I'm looking to the rule. Reflect across what? X-axis. So x is going to be still x. Y is going to be what? Negative y. That means x is going to still the x. Y is going to be what? Negative y. So check what is going to happen in the new graph. -2 and -4, right? -2 and -4 is going to be here. This one is going to be here. This is here. This is here. What happened to the new graph? New graph. This is the old one. Reflect over x-axis. Okay. Reflect over y-axis is going to be how? This one reflect over y-axis is going to be the same graph. Because we're gonna flip this one here and flip this side here. So we're just gonna switch it. It'll be the same graph. So the best reflection to do is with this function. If you reflect it over y-axis, the square root of x is going to be here. So okay, kind of.
I have a question.
Yes.
Can you give me an example how the reflection would look like if you would write it out? Like right there where,
Like this one?
yes, but if you flip it around on the y-axis, like how would
On
it?
the y-axis. That's why I'm telling you with this one.
Oh,
At the square root of x. Because if with this function,
it's gonna look the same either way.
it's gonna be the same. Yeah, like we can't tell. Like
But would it have parentheses and the minus sign inside the parentheses?
let's say meant like this.
Oh no.
Like the top one, right?
Yeah, I'm saying like the top
Oh,
one.
like this one?
Yeah,
Oh, yes, that's a good one.
because right there on where it says reflection, it says y equals negative f in the parentheses.
Oh, okay, I got you. Like we have to change the whole function. That we say f of x equal, let's say negative x plus 4. Squared. I have to do that. Because if I put just negative x squared without this number, it's gonna go back x squared.
Oh, it's the same thing.
It's still the same thing. Because this function, if you do reflection over y, just you're gonna switch it. It's gonna be the same thing. But to visualize, do reflection over x, yeah, you can tell. There's the new function. And the same thing with square root of x. The basic function, square root of x like this. When you do reflection over y, the new function is going to be where? On this side. That's kind of the main thing. If you go to the last page. I'm not gonna stick with the example they have. Let's do several examples. Negative half x squared minus 4 x minus 4 plus 5. Now tell me, how many transitions do we have? Start from here. From here, keep going to the. First of all, where is the basic function? The basic function is
X squared.
x squared. Now let's check here. X squared, which is here, right? If there's negative sign outside the x squared, what's going to happen? Reflect over what? X-axis. Okay? Now, if there is 1/2 outside, what's going to happen? It's going to be what?
Shrink it.
Shrink it, but it's going to be vertical or how's it? It's going to be vertical or shrink. So this one is vertical shrink. By. Is that okay? Now the third one. By 2.
We're gonna move it up 5.
Okay. Now before we finish from these two, right? We're gonna go inside. Now inside there's minus 4, so it's gonna be shift
To the right.
how many units? 4 units. Now number 4. We're gonna go outside. 5. Maybe shift up. How many units? Is that okay so far?
Why does it say like the order differently at the bottom?
It doesn't matter. It doesn't matter. Like we're talking about this one.
Yeah.
It doesn't matter. It doesn't matter. But the main thing, you have to write down all the transition. If you write down the reflection, the last thing, it's going to be still right. So don't worry about which one I'm going to start with. I'm going to start from this one. You're going to start this one, but you have to write down all the transition. Okay? So it doesn't matter which one you're going to start with. One more. Choose absolute value. We have f of x equal, let's say, -2, absolute value x plus 4 plus 6. Doesn't matter. Now tell me, which one are you going to start with? I don't. I say no. Which one? You're going to write down this on the test. Tell me the first transition. Oh, okay, let's say reflection over x-axis. Tell me another transition.
Stretch it.
Stretch it by vertical.
Vertical stretch.
By 2. Next.
We're gonna shift it to the, what is it, to the left.
Shift, left. How many units?
4.
4 units. Next.
Move it up 7.
Left up.
So like, is that the correct way to write it out? Like in
When I'm writing it down, I always look from the left to the right.
right?
But again, it doesn't matter which one you're gonna write down.
Okay.
You're gonna start from here, shift up, then shift left, then stretch, better stretch, then reflect. It doesn't matter.
Now in the same
It's
place.
the same thing. Is that okay so far? Need to work on the homework. We're not gonna forget.